everybody, and welcome once again. Uh, Today I'm going to start with a topic called sequences and series. Okay, and this is for the IBDP level, and this is for the SL students. Okay, and from the approach and analysis, right? So it's a good book called I don't remember the author, but it's a Oxford publication book of IB, and the sequence and series is something that I'm going to start with today, right? So let us get started with, and first of all, I want to tell you certain things about this topic, sequence and series. We started studying about these sequences right from our school days as early as 6th grade, and I think everybody should agree with that. Pattern wise study of the sequence was the start. Okay, so initially during the school days, we were taught how the patterns, were formed, okay, in sequence making, followed by the nth rule and the term to term rule, etc. Okay, so then we proceeded to find out the nth rule, or something called term to term rule, or position to term rule. All these things were used, okay, in the understanding of this sequence and series. Thereafter, we came across the concepts of AP and GP. Now, AP and GP, as everybody knows, it stands for arithmetic progression and geometric progression. These are two very basic type of sequences. Apart from these two, you have many other sequences which are neither AP nor GP, and there are many other sequences which are known as harmonic sequence and many other sequences. Okay, there's no end to that. But then AP and GP is what we studied in our school days, arithmetic progression and geometric progression. Then we felt the need to understand the difference between sequence and series. Okay, so once we understood what are the different types of sequence, then we tried to understand what is the meaning of series and what series actually is. The terms of the sequence, when we try to find out the sum of certain terms, okay, or all the terms, we actually say that we are trying to find out the series of that particular sequence. Okay, so series is nothing but the sum of all or sum of some particular terms of a sequence. Sigma notation, which is also known as denoted by this particular symbol. Okay, this is sigma notation, and it has a profound use in this sequence and series questions. Okay, so this was used in algebra, and its importance increased in this sequence and series topic. Then in binomial theorem also we studied something called permutation and combination, the Pascal's triangle, to find out the coefficients, okay, of the terms. We used to use that combinations. Okay, so all these were also related to sequence and series, which played an important role in sequence and series. Okay, so all this thing, when you sum up, okay, ultimately, then if you restart your sequence and series topic, okay, so that is what the idea is. I'm going to start today with the collection of all these ideas taken together, and let us try to approach this topic of sequence and series. Now, before we start with this sequence and series, okay, let us try to understand certain things like solving the linear equations. Now, these are very basic things, I know, everybody knows. 2 times x minus 2 is equal to 3 times 3x plus 7 is equal to 4. Now, if you want to solve it, it's a linear equation. You can find out x equal to minus 29 upon 7. So these are basic things. Now, this is how to add and how to do algebra of fractions, right? So that is also, I think, it's not something to discuss now. But anyway, these are the things that you should know before we start with the actual sequence and series. Okay, so now let us try to understand the following situation. Now, if you want to give a very fresh uh, you know look to this particular sequence and series topic, okay, let us take this very particular example, which is very very uh, you know simple, as well as very very straightforward and very very relevant to the topic. Okay, now I don't want to go into the entire explanation of this situation, but I'll tell you what is this. It's an investigation in which there are two people. One is called Luis, Luis. Okay, so you can see this fellow Luis, and there's another fellow whose name is also, I suppose, it's something Elijah or something like that. Okay, sorry if I'm not pronouncing it properly, but then these are the two people, and what happens is both of them, are joining a gym. Okay, so this particular fellow, let me call it A, and this one B. Okay, so A is joining a gym which is taking a down payment of $100 initially, and then when you go for the sessions, every time for the you know to use that gym. Okay, so every time he's going to charge you $5. Okay, is that clear? So that is how this A is planning to join a gym where you have to initially pay $100 kind of initial down payment, and then every time when he uh, you know goes subsequent days, when he goes for the gym, he has to pay just $5, right? So for if he doesn't go, if he doesn't do any workout or anything over there, he has to first pay $100, right? So once he pays $100, then the very first time if he goes and he takes the advantage of that gym, he is going to pay $5, right? Next time when he goes, he'll pay one more $5. So every time he's going to pay $5, right? So that's how he's going to pay for the this thing. Okay, so basically what happens is uh, okay, okay, so total fees that is paid, okay, will be this way. Okay, so $100 in the beginning, then every time when he goes, he's going to pay just $5, right? Okay, that is for A. B also joins a gym, but he joins on different terms and condition. He doesn't have to pay that compulsory $100. Okay, on the contrary, every time when he goes to the gym and he uses that gym, he works out over there. So every time when he goes, he has to pay uh, some $15. Okay, 1 5. So today he has paid $15. Next time when he goes, he'll pay $15. Next time when he goes, he'll pay $15. So every time he goes, he'll pay $15. Right? Suppose let us try to see that for 10 days what happens. So for in the case of A, first he's paying $100. Okay, and then he goes for the first time to the gym to work out, and that time he pays $5. So the expenditure so far is 105, 100 that he has paid as down payment, and $5 for that particular day. Next day when he goes, he pays another $5, so his total expenditure now happens to be 110. That way his expenditure goes on increasing, like from 100 to 105, 110, 115, 120, 125, that way. Okay, so probably after 8 days, okay, he will be already spending $140. In the case of B, he is paying for the first time when he goes, he pays $15. Next time he goes, he pays another 15. So for the second day, he has spent $30 already. So that way, after some 8 days, he has spent some $120. This is how it works. Okay. Now, in this situation, we come across two types of sequence. In the case of A, you can write UA. The sequence happens to be, so if you want to write in the language of sequence, UA, in the case of this fellow, it will be 100, which he has paid in the beginning, and plus every time he visits, he has to pay $5. So 100 plus 5 into 0, right? That way. So this is his, when he goes for the first time, he pays this much. Okay, so the thing is, every time he goes, he has to pay $5. So $5 is being added to the fees every time. So it's a case of AP. Okay, we have studied already AP, so that is why I'm not going into detail. But I'll tell you the sequence for A, UA, can be written as 100 plus n minus 1 times D in general. A is the first term, that is 100 rupees he pays, $100. Okay. So this will be 100 plus 100, sorry, it's not, yeah, 100 plus n minus 1. D is $5. Okay. So this, if you work out, it will be 100 plus 5n minus 5, which works out to 95 plus 5n, or rather 5n plus 95. So this is the sequence or the formula, or you can say the general term for A. In the case of B, okay, UB, the general term has to be uh, like it should be, how we are going to calculate for that. Okay, so it will be 15 times n minus 1, right? Suppose on the very first day if he goes n equal to 1, okay, so 1 minus 1 will be 0, 15 into 0 will be 0, okay. So first day if he goes, okay, it will be $0. Then next time when he goes, it will be 15 into 2 minus 1, so that way it will be 15 into n minus 1, which works out to 15n minus a 15. So this happens to be the nth term for that B fellow. Okay, so these are the two things, right? Now the question arises is, what will be, or how, after how many days both will have spent the same amount of money. Okay, so for that we'll have to equate UA equal to UB. So that I have done here. So first I did the try and test method. Okay, suppose let us say after 11 days what happens. Okay, so after 11 days in the case of A, okay, UA is equal to 5 into 11 plus 95. Okay, and sorry, UA is 95 plus 5. Okay, yeah, so n is this is U11, okay, for UA. After the 11 days it will be 11 into 5, okay, plus a 95, that works out to 55 plus a 95, which is equal to 5 plus 5 10 0, 1 carried, 9 plus 1 10, 10 plus 5 15. So $150 is spent in the case of A. In the case of B, after 11 days, okay, the total amount paid by B will be 5 times n plus 95, no, sorry, 15n minus 15. It will be 15n minus 15. You have to take this. Okay, 15n minus 15. So this will be 15 times 11 minus 15, and this also works out to 150. So you can see that after 11 days, both have paid $150. So if a question arises after how many days both have paid the same amount of money, then the answer should be after 11 days both have paid the same amount of money. So this type of question are the forte of this sequence and series type of questions. Okay, so let us revisit this sequence and series, and let us try to understand this in a new light. So now look at the following sequences and see if you can determine the next few terms in the pattern. Okay, now the first one is this one, 2 4 6 and 8, right? So by looking at it, you know that the next few terms will be what. Okay, so this is 2 4 6 8, so next should be 10 12 and 14. Very straightforward. For 2 it is 14 11 8 and 5. Okay, so 14 minus 3 is 11, 11 minus 3 is 8, 8 minus 3 is 5. So each time when you go from left to right, 3 is being reduced. So in the chain, after 5, 5 minus 3 will be 2, 2 minus 3 will be minus 1, minus 1 minus 3 will be minus 4. So this is also understood. Okay. In fact, these two are nothing but AP, because something is getting added or subtracted as you go from left to right in the sequence, right? So these both are AP. Third and fourth, let us see. Third one is 1, 4, 9 and 16. Now this is very clear from the pattern. You see that 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. So the next should be 5 square, that is 25, 6 square 36. So this should be the pattern: 1, 4, 9, 16, and then 5 square, 6 square, 7 square. This is clear. The fourth one is 1, 3, 9, 27. Now this is 1 multiplied by 3 is 3, then 3 multiplied by 3 is 9, 9 multiplied by 3. So every time you go on multiplying by 3, this type of series sequences are known as GP, okay, where you multiply out and you get the next term. So this you will multiply every time by 3. So 27 into 3 will be 81, 81 into 3 will be 243, and 243 into 3 will be 729. Okay, these were very straightforward 4 questions where we try to understand what sequences are. Okay. Now for all these sequences, you have a formula or an expression that mathematically describes the pattern of the sequence that can be found, and this is known as the general term or the nth term, okay, which is written as either un, in some book they write as an, whatever, okay. So this is the general term and it has some formula, right? So this formula can be derived by many ways. Number one is by observing the pattern. Second is by understanding what is AP and GP, okay, and there are many other ways, okay, but mostly pattern and the AP GP formula, are very useful in describing this sequences, which are known as the general term or the nth term also. Okay, fine. Now let us come to exercise 1A and try to see what the questions here says. And going by this question number 1, sub question A, write down the next 3 terms in each sequence. So A is -8, -11, -14 and -17. You have to write the next 3 terms, okay. So the question doesn't tell you to identify the sequence, but it is always advantageous to identify the sequence, okay. So -8, -11, -14, -17, these are the first 4 terms, okay. See how to approach this. From -8, if I -8 -3 if I do, so I get -11, okay. -8 -3 is -11. -11 -3 again if I do, I get -14. -14 -3 if I do again, I get -70. So in the pattern you see that every time -3 has to be added to the previous term to get the next term. So after -17 you should get -17 -3, which is -20. Can you see I've worked out over here? Then -20 -3 will be -23, okay, that is this, and then of course -26, right? So A is understood, right? So it's an AP because -3 is added every time to the previous term, okay. This is an AP, okay. B, 9, 16, 25, 36, okay. 9 plus how much is 16? 9 plus 7 is 16, okay. Then 16 and 25, what is the difference? Okay, 16 plus 9 is 25, okay. Here what is happening is it looks like an AP, but it is not AP, because in AP the same constant number has to be added or subtracted, okay. Like in this A, it was -3 which was getting added to the terms, okay. Here you see that there's no constant being added, okay, or subtracted, okay. It's changing. 9 plus 7 is 16. 16 plus 7, if you had some number over here, then it was okay, but you have 16 plus 9 which works out to 25. So here you are adding 7 to get 16, and here you have to add 9 to get 25, and here you have to get 11 to get 36. So these 7, 9, 11, these are not the same number, not constant number, so it's not an AP, Okay. If it's not AP, go for GP. Check whether it is GP. To check GP, we always take the successive term and divide by the previous term. Okay. So in this case, successive term is 16 divided by 9. So 16 divided by 9 should be equal to 25 divided by 16, and if this is true, then it can be GP. Okay. Now 16 divided by 9 and 25 divided by 16 are both not the same thing. Okay, so this is not a GP as well. Or in other words, if you want to understand in another way, so instead of finding a constant number being added or subtracted, you try to find out a constant number being multiplied. Okay, from left to right. So 9 into something should give you 16, and 16 into that same thing should give you 25. 25 into that same number should give you 36. If that happens, then it would have been a case of a GP. So here in this case of B, we see that it is neither an AP nor an GP. Okay? It's neither an AP nor a GP. Moreover, you cannot see any pattern also. Rekha. Moreover, you cannot see any pattern also. Okay. Moreover, you cannot see any pattern also. Okay. So in such cases, what you can do is try to see the difference in the terms, and see I have worked out over here. This is one of the methods that you must have studied in your school days. Okay, IGCSE 10th grade. I remember I have taught this to the IGCSE 10th grade students, right? B wala. So it is 9, 16, 25, 36. These are the terms. This is first term, second term, third term, and fourth term. Okay, so these are the position number n, and these are the term numbers, that is un. Okay, u1, u2, u3. Okay. Okay. Now the first difference is 16 minus 9 is 7, 25 minus 16 is 9, and 36 minus 25 is 11. So I can see that the difference is not constant. So first difference is not constant. So you are getting various answers, 7, 9, and 11. Okay. Let me try the second difference. So 9 minus 7 is 2. 11 minus 9 is also 2. Here I am getting a constant difference. Okay. So in the second attempt or in the second line, I am getting a constant. So second difference is constant. So whenever a first difference happens to be constant, okay, the AP is un equal to a plus an plus d. Okay, un is equal to a n plus b. Okay, it's a linear equation. But once you get in the second line or in the second step, if you get constant, then your general term or the un will be equal to a quadratic expression. So it will be an square plus bn plus c. Okay, an square plus bn plus c. Suppose in the second attempt also, or in the second line also, you don't get a constant. So try in the third attempt or third line, and suppose you get the constant in the third one. So your un will be a cubic one. A cubic expression can be written as an cube plus bn square plus cn plus d. Okay, so this is that method which we can use in this case. So we know that in the second line or in the second difference we get the constant. So we know that the general term has to be somewhat of this form, an square plus bn plus c. Now using this, assuming that this is the general term of the sequence, if you put n equal to 1, you will get a plus b plus c, because when you put n equal to 1 in this formula, you will get u1 equal to a plus b plus c, and u1 is nothing but 9. So you can write a plus b plus c is equal to 9. So that is what I have written here. This is the first term, which is a plus b plus c, which is actually 9. The second term will be, for second term we will have to take n as 2. So it will be 4a plus 2b plus c. Okay, see, 2 square is 4, so 4a, and n is 2, so 2b plus c. So 4a plus 2b plus c. This is the second term, and second term is 16. So I am writing in this way. Same way, third term will be 25, that is 9a plus 3b plus c, and the fourth term will be 16a plus 4b plus c, which is 36, right? Then let me write this 7, 9 and 11 also in the same way. Now this minus this will be 4a minus a is 3a, and 2b minus b is b, and c will cut off. Okay, so this minus this difference will be 3a plus b, and 16 minus 9 is 7. So 3a plus b is 7. Same way here, 9a minus 4a is 5a, and 3b minus 2b is b. So 5a plus b will be 9. Same way here, 7a plus b will be 11. Got it? And then this difference, if you see, 5a minus 3a will be 2a, b minus b is gone. So 2a is nothing but 2. And here also 7a minus 5b, 2a is equal to 2. So we get from this constant 2a is equal to 2. So when 2a is equal to 2, obviously a will be equal to 1. So in this particular general term, we got the value of a as 1. Okay. Now let us put this value of, let us try to find the value of b and c as well. Okay, a we have found out, it is 1. Let us try to find out b and c. So we can take these two equations. These are two simultaneous equations. Okay, I am sorry, these two you can take. Okay, these are two linear equations in two variables. Okay, a and b. Right. So let us try to solve this equation. So 3a plus b is 7, and 5a plus b is 9. Okay, we get it from here. Now if you go to solve this, you get 9 minus 7 is 2, b minus b is 0, 5a minus 3 is 2a. So 2a is equal to 2. So a is equal to 1 we got. And now suppose we put the value of a as 1 in any of this equation. We get 3 into 1 is 3, plus b equal to 7. So 7 minus 3 is 4. So we get b equal to 4. Now we got a equal to 1, b equal to 4. Now use this equation, a plus b plus c equal to 9. Okay, so using that equation and putting the values of a as 1 and b as 4, 1 plus 4 plus c equal to 9. So c will be equal to 9 minus 5, that is 4. So this is how I got a, b and c all three. So this general term that I had got un equal to an square plus bn plus c can now be written as un is equal to n square plus 4n plus 4. Am I right? B is 4 and C is 5. I'm sorry. 9 minus 5. Yeah, C is 4. Okay. 1 second. B you got as 7 minus 3. 1 second. A is equal to 1, B is equal to 4, and C we are getting as 5. Okay. C should be 9 minus 5 is 4. C we are getting as 4. Okay. Fine. So this I allow to do the correction. C is nothing but 4. Okay. So now your general form of the equation happens to be n square plus 3n plus, see all this thing. Okay, I think there is some mistake I have done somewhere. A plus b plus c is 9, a is 1, b is 4, so c will be equal to 4. That's correct. Okay, b is also 4. Okay, correct. C is 4, b is 4, and a is 1. So your series happens to be n square. Now this I'll have to do correction. B is 4, right? So I'll have to take 4n plus 4. Okay, fine. Now if you want to find out the next three terms, so u5 will be equal to 5 square plus 4 into 5 plus 4, right? Now this is correct. Okay, so fifth term, if you want to find u5, then it will be n square, that is 5 square, 4 times n, that is 4 times 5 plus 4. So 5 square is 25, 5 4s are 20 plus 4, so this happens to be 49. Next term, the sixth term will be 6 square plus 4 into 6 plus 4, which is 64. And the seventh term will be 7 square plus 4 into 7 plus 4, which is 81. Okay. So in this case, we see that it was not easy to determine the uh, general term. Okay. So it was a lengthy method, but ultimately we got the terms as uh, which question we were doing? Yeah, question number this B. Okay. So here we got the answer as 49, 64 and 81, right? Let us check. 49, 64 and 81. That's correct. Okay. 49, 64 and 81. Okay. Then let us go on to the next one, C. This is that C. The sequence you can see is 6, 12, 18, 24. Now this is a sequence where from 6 to 12 if you want to go, you add 6. From 12 to 18 if you want to go, another 6 you add, another 6 you add. So this can be taken as a AP where the common difference is 6. So for this type of question, you can see 6 to 12 plus 6, 12 to 18 plus 6, 18 to 24 plus 6. So this plus 6 is known as common difference, which is your 6, which is denoted by D. And for AP, the UN is equal to A plus n minus 1 times T, where A is the first term. In this case, the first term is 6. So it will be 6 plus n minus 1 times D is also 6 in this case. So D will be 6. Okay. So your general term works out to 6 plus 6n minus 6. So this goes. So this is nothing but 6n. Okay. So the answer is 6n. Alright. Using this general term, we can find out the fifth, sixth, and seventh term. So fifth term will be 6 times 5, so 30. Sixth term will be 6 by 6, 36. Seventh term will be 6 into 7, 42. So 30, 36, and 42 should be the answer. D. This one. D. 1000, 500, 250, 125. Here you can see it's a case of GP. Okay. You can see 1000, 500, 200, 250 and 125. So from 1000 to 500, if you want to go, you multiply by a half, you get 500. 500 you multiply by half, you get 250. 250 you multiply by half, you get 125. So what you multiply is known as the common ratio CR, denoted by R. So your R is equal to half. Your A is the first term. A is what? The first term. In this case, the first term is 1000. Okay. And for a GP, the general term, the formula is A R raised to n minus 1. So putting in the values, for A you put 1000, for R you put half raised to n minus 1. So this is the formula for your general term of this sequence. Now using this formula, you can find out U5, U6 and U7. So U5 will be equal to 1000 into half raised to n minus 1 means 5 minus 1. So it will be raised to 4. That works out to 1000 into 1 by 16. So 62.5. U6 will be equal to 1000 into 1 by 2 raised to 5. That works out to 1000 into 1 by 32, which is 31.25. And the seventh term will be 1000 into 1 by 2 raised to 6. So 1000 into 1 by 64, which is 15.625. So these are the next three terms. So you will be 62.5, you get 31.25 and 15.625. It was an GP. Next is E. E is 1 by 2, 2 by 3, 3 by 4, 4 by 5. Okay, so let us see. It's in the form of a fraction. So in the numerators, this one. Okay, in the numerators you have 1, 2, 3, 4. Okay, so this is having a general term of you can say n. Okay, n equal to 1, 2, 3, 4. and in the denominator you have 2, 3, 4 and 5. So first this is a AP, okay, or you can just write n plus 1. When you take n equal to 1, 1 plus 1 will be 2, so first term is 2. When you take n equal to 2, it will be 3, so second term is 3, third term is 4, that way. So you get n plus 1. So your un will be equal to n upon n plus 1. This is the general term, okay. Now if you want to find out the fifth term, okay, just put n equal to 5 and work out. So it will get n upon n plus 1 will be 5 by 6. Sixth term will be u6 will be 6 upon 7. Seventh term u7 will be 7 upon 8. So these are your answers: 5 by 6, 6 by 7, 7 by 8. That was E. Now moving on to F. 1 by 3, 2 by 9, 3 by 27, 4 by 81. Again here the numerator, the general term will be n. Denominator, the general term, you can see the pattern is 3 raised to n. 3 raised to 1 is 3, 3 raised to 2 is 9, 3 raised to 3 is 27, 3 raised to 4 is 81. So you get 3 raised to n. So your un will be equal to, in the numerator you have n, in the denominator I have 3 raised to n. This is the formula, okay. Using this, the fifth term will be what? So u5, it will be 5 upon 3 raised to 5, okay, which works out to 5 upon 245, okay. Sixth term will be 6 upon 3 raised to 6, that is 6 upon 729. The seventh term will be 7 upon 3 raised to 7, so 7 upon 2187. So these are the next three terms. So 5 upon 245, 6 upon 729, 7 upon 2187. Fine. So that was our starting of this sequence and series. We started at a very easy note, okay, and today the time doesn't permit me to go ahead. So next time I'll be coming with you and doing this question number 2 onwards, okay, from this exercise 1A, and we'll be proceeding, okay. So as far as possible we are going to do each and every questions from these exercises, and we'll see that we are, building up a very sound foundation, or a very good thorough knowledge of this sequence and series, because now we are dealing with sequence and series at a level which is Ibdp, okay. And that's all for today. So next time we'll continue from question number 2 onwards. See you. Bye. Take care, all of you.